Hi, I'm Dr. Tess O'Hara and I'm a technical advisor with the Pro Wash and Scale team. And today we're going to put a spotlight on nitrate in water. The first question that we'll answer is, what is nitrate? It's a common chemical compound made of nitrogen and oxygen, and the chemical symbol for that is NO3. It's highly soluble in water. It does occur naturally, but it's often an indicator of human activities, including the use of nitrogen-based fertilizers and the presence of animal or human waste. The problem is that in drinking water, it can reduce the ability of an infant's blood to carry oxygen, and long-term exposure could be a cause of cancer. One of the important reasons for looking for nitrates in water is that it's an indicator of the presence of human waste, animal waste, or these fertilizers. So it's often a good way of identifying issues that might exist in the catchment for the water supply, and something that we'd want to follow up on. So even if it doesn't cause a health problem, it's an indicator of a wider issue in the environment. And it's especially important if the concentrations of nitrate are increasing with time, because it's something that we'll want to tackle before we have problems like pathogens in the water. There are guidelines for the concentration of nitrate in drinking water. The WHO recommend a maximum concentration of 50 milligrams per litre of nitrate, while the US EPA, which USAID use as their guideline, recommend a maximum of 10 milligrams per litre of nitrate as nitrogen. And this can be where some confusion lies. Because these are different things, nitrate as nitrogen is a way of expressing the amount of nitrogen in the nitrate molecule, and that allows comparison with other nitrogen-containing species like nitrite, ammonium, organic nitrogen, total nitrogen, and total colloidal nitrogen. And these are important nitrate-bearing compounds that we look at for different types of water investigation. But for the WHO and for a lot of analytical methods, the concentration of the whole molecule, NO3, is reported. If that's confusing, don't worry. It causes a lot of problems. So we're going to go back to the beginning and explain why this is. We're going to have a quick chemistry lesson. Here you can see the nitrogen and oxygen atomic weights. And these are important because this gives us the molecular weight of the nitrate. The atomic weight of nitrogen is 14.1 and the atomic weight of oxygen is 15.99. So when we add all those up together, we get a molecule weight of 61.98. And the next slide, we'll have a look why that's important. Sometimes you might find that you've been given a lab report that tells you nitrate values, or the analytical method that you've used gives you the nitrate, but you might have a guideline that is nitrate as nitrogen. And this is quite common if you're working with US EPA guidelines. We've done an example here of how to convert 50 milligrams per litre of nitrate into nitrate as nitrogen. And you can see now why we needed the atomic weight of nitrogen and the compound weight of nitrate. What we do is we take the value that's been reported on our lab report, and in this example, 50 milligrams per litre of nitrate. We divide that by the molecular weight, which is 61.98, and we multiply it by the atomic weight, which is 14.01. So 50 milligrams of nitrate is the same as 11.3 milligrams per litre of nitrate as nitrogen. Sometimes the opposite might be true. You may have been given nitrate as nitrogen and you want to know what the nitrate concentration is. Or, in this example, if you want to know how the guidelines compare, we need to convert nitrate as nitrogen into nitrate. This gives the worked example, and again we use the molecular weight and the atomic weight to help us with the calculation. 10 milligrams per litre of nitrate as nitrogen is multiplied by the molecular weight, 61.98, and then that's divided by 14.01, the atomic weight of nitrogen, and that gives us a total of 44.23 milligrams per litre nitrate. From this, you can see that the US EPA guideline, which is used by USAID, is slightly more conservative. The nitrate can only reach 44.23 milligrams per litre nitrate under US EPA guidelines compared to WHO, which is 50 milligrams per litre nitrate. This is a relatively small difference, so it's not something to be too concerned about because, as we said at the beginning of the presentation, one of the most important things to know about nitrate is whether it's changing. If it's increasing, then we know we have to start looking around the catchment to find out what might be causing that. To summarise, you must always check which value has been reported and which guideline you are working to. We know that WHO is 50 milligrams per litre nitrate and the US EPA or USAID guideline is 10 milligrams per litre nitrate as nitrogen. I've given you the molecular weight and the atomic weight so you can do the conversion yourself, or as a quick alternative, you can just multiply by the factors shown here on this slide. As I've gone through this presentation, if you've been listening carefully, you might have noticed that I've tripped up over my words a couple of times. Is it nitrate as nitrogen or nitrate? It's really easy to get these mixed up, so don't worry if you're not sure and refer back to the slides if you need to go through it again. I did, and I wrote them. To conclude, I'd like to say thank you for listening. I hope that you found this useful. If you do want any more information, you can see some references online. There's the direct link to the US EPA guidelines, the WHO guidelines, and if you want more in-depth information about this, there is a ProWash water quality training course that's available online. You can always reach out to the team and we'd be happy to answer any questions that you have. Thanks very much for listening and have a great day.